Okay, another ministry question. Which of the following functions has no vertical asymptote at x equals 2? I'm gonna check vertical asymptote of each option one by one. Option A. I am going to rewrite each function one by one. Rewrite each. So after simplification, I will decide whether the number that makes denominator 0 is our vertical asymptote. So option A. I can do that because top and bottom are both polynomial. So x squared minus 4 can be rewritten as x minus 2 times x plus 2 divided by x minus 2 squared. Now cancel out the common factors, which are x minus 2 and one of the x minus 2's from the bottom. So what remains in the denominator? X minus 2 remains. So what makes denominator 0? X minus 2. So if x minus 2 is equal to 0, x equals 2 is vertical asymptote. So it has vertical asymptote at x equals 2. Option A has. What about option B? Option B, let's rewrite option B too. X plus 2, numerator stays. Denominator, x squared minus 4 is x minus 2, x plus 2. So simplification, x minus 2's will cancel each other. What remains in the denominator? X minus 2. That makes denominator 0. So when x minus 2 is 0, x equals 2 is vertical asymptote. So B also has vertical asymptote at 2. What about C? Option C, x squared plus 4 is not factorable. You don't touch it. At the bottom, you do factorization. Xx, xx, so this one, 2, 1, but the middle term is minus. They are both minus. X minus 2, x plus 2. No simplification. X minus 2, x minus 1. Let me correct the mistake. X minus 2, x minus 1. So what are the vertical asymptotes? X minus 2 is 0, x is 2, x minus 1 is 0, x is 1. So there are two vertical asymptotes. X equals 2 is one of them. So this also checks x equals 2 is vertical asymptote. So option C also has vertical asymptote at x equals 2. So apparently option D is our answer. So just to explain how, I'll explain the two. Option D, let's rewrite. You do factorization at top. X, negative 6 is 3 times 2. One of them will be negative. Since the middle term is positive, the bigger number will be positive. The smaller one is negative. So x minus 2 times x plus 3 at the top. At the bottom, 2 is common. X squared minus 4 remains. So 2 multiplied by, you can also expand x squared minus 4 as x minus 2x plus 2. So there is cancellation. X minus 2's will cancel each other. X plus 2 remains in the denominator. This is what makes denominator 0. So when x plus 2 is 0, x equals negative 2 is vertical asymptote. What are we looking for? I'm looking for my vertical asymptote to be x equals 2, not negative 2. So that option doesn't have a vertical asymptote at x equals 2. Right? So let's move on. 2023 first attempt mystery question. The vertical asymptote of which one is 1 plus 2n? 1n is an integer. We checked this in the previous questions. We also checked this in the previous questions. It is none of it. Let me check B. You go back and check the answers for these two. Option B, tangent. I'm going to rewrite the tangent as sine over cosine over cosine. So it's a kind of a rational expression. What makes denominator 0 will give me vertical asymptote. So what makes cosine 0? The angle being equal to pi x over 2, being equal to pi over 2 plus n pi, where n is an integer. You either use z or I, they both represent integer. So isolate x, you multiply both sides by 2 over pi, by 2 over pi, by 2 over pi. So x is alone on the left, on the right, 2's will cancel each other. 2 over pi, pi's will also cancel each other. You'll have 1 here, plus, and pi's will cancel each other. You have 2n. So x is equal to 1 plus 2n, where n is an integer. So it is option B then. Alright. So what makes cosine 0 doesn't make sine 0. So you don't need to check whether the numerator is 0 or not. So it is the answer. Okay, another ministry question. It's a true-false question. Which one is false? A polynomial function has no vertical asymptote. It is true. In order for us to have vertical asymptote, it should be rational, but not every rational has vertical asymptote. The second option, every rational function has vertical asymptote, which is totally false. For example, let's say 1 over x squared plus 1. X squared plus 1. There is no x value that makes denominator 0. So no vertical asymptote. So just because we have a rational expression doesn't mean that there is a vertical asymptote. So option B is false. Option C, the function has no point of discontinuity, which is impossible because it's rational. What makes denominator 0 will be our point of discontinuity. So negative 2 is point of discontinuity. That's also false. So we have two falses, B and C. B and C is in option D, written as B and C together. All right. There is another question about the same function in G and C. Which of the following is true for the function? The vertical asymptote is x equals minus 2. So what was the definition of vertical asymptote? It is the number that makes denominator 0 only, not the numerator. So when you equalize denominator to 0, you get negative 2. But it shouldn't make numerator 0 too. When you insert negative 2 in the function, you're going to get 0 over 0. So x equals negative 2 is not your vertical asymptote. In order to have vertical asymptote, the result should be number over 0. Number other than 0 over 0. But your result is 0 over 0. So that's false. It's not your vertical asymptote. Option B, f is continuous at x equals negative 2. We just talked about it in the previous question. It is discontinuous. It's not continuous at x equals negative 2. It's what makes denominator 0. So option B is also false. Option C, f is discontinuous at x equals negative 2. True. With non-removable discontinuity. So let's check this. We don't know whether the discontinuity is removable or not, so we check it. How do you check the type of discontinuity? By checking the limit. So if we have non-removable discontinuity, so limit at x equals negative 2 should not exist, right? So check the limit then. How do you check the limit if the function involves absolute value? We check two-sided limit. Limit as x approaches to negative 2 from the left, and limit as x approaches to negative 2 from the right, one by one. From the left, when you give a number less than negative 2, like negative 2.1, the inside will be like negative 2.1, the inside will be negative. If the inside is negative, you take out the opposite expression, negative x plus 2 over denominator stays same. Result is negative 1. For the positive side, when you pick a number greater than negative 2, like negative 1.9, negative 1.9 plus 2 is 0.1, which is positive. So you take out the same expression. Denominator will not change. Result is 1. So left-sided limit gives you negative 1. Right-sided limit gives you positive 1. So since right and left sides are different, then limit does not exist at x equals negative 2. So it has non-removable discontinuity since limit does not exist. So that part is also true. So option C is true then.